All right, in chapter 8, we are wrapping up our lessons on trig. This is the third chapter, and we're only going to do part of it. So we're going to do a little mini section with just 3 sections, then we'll have a review and a quiz after that. But the first sections is application involving right triangles. And yes, applications do mean story problems. All right, so we're going to eventually work with some story problems. And in section 1, we're dealing with right triangles, and all of our trig so far has been right triangle trigonometry. But sections 8.2 and 8.3 are not right triangles. Okay, and we're going to look at ratios of sides and angles in triangles that are not right triangles. All right, so just looking on the first page here, we have things that we already know. And I'm not going to go over each part of it, but these are our trig ratios and their side and the sides that represent those ratios. Like sine is opposite over hypotenuse, and this is where we have SOHCAHTOA. And these are the reciprocal trig ratios that we've been working with. And where these come from, the A over C and the B over C, they come from a right triangle. So I'm going to just draw this right triangle. And usually in a right triangle, we label the angles. Angle C is always the right angle. And then it doesn't matter with A and B, but we label the angles with capital letters, and the side across from them is the small letter that is consistent with the angle. So across from C is side C. Across from angle B is side B, and the same with A. This first part, we actually kind of already know this. I don't think we've talked about it officially being a theorem, but here it says that cofunctions of complementary angles are equal. All right, and when we talk about cofunctions, these are not our inverse functions. These are the functions that go together, like sine and cosine, tangent and cotangent, secant and cosecant. These are the co-functions. And if we have complementary angles, like in this one we have sine of 30 is equal to cosine of 60, well, we already know that because on our unit circle, if I have a 30-degree angle, the coordinates of that are square root of 3 over 2 and 1/2. And if I have a 60-degree angle, the coordinates of that is 1/2 and square root of 3 over 2. All right, so remember this represents cosine and this represents sine. So the cosine of 30 is the same as the sine of 60. And the sine of 30 is the same as the cosine of 60. So we already knew that these were the same numbers. This just gives it a name for a theorem, and that works with any complementary angles. So if I have a 40-degree angle and a 50-degree angle, tangent of 40 and cotangent of 50, I could do sine of 40 equals cosine of 50. All right, so it doesn't matter which pair I use in terms of the trig ratios, but those cofunctions are equal if they're with complementary angles. Okay, and we can actually look at this down here to see that where it says sine of B, and I'm going to go back up here and look at that, is opposite over hypotenuse. and that's equal to cosine of A, which is also adjacent, which is B over hypotenuse. So B over C. So sine of B and cosine of A are both B over C. All right, so in this first example, it says we have a rain gutter, and it's being constructed out of aluminum sheets that are 12 inches wide. After marking off a length of 4 inches from each edge, this length is bent up at an angle of theta degrees. So here's my aluminum sheet, 4 inches here and 4 inches inside here. And then they lift those sides up. Okay, so what we're looking at, I'm just going to draw this picture here. Okay, so this side is 4, this side is 4, and if the whole length was 12 inches, this side is going to be 4. So this is going to be my angle, and up here, I've got this other side here, and I've got this other triangle here. I should say. Let's do this. So this side is 4, and I've got this here and this here. So really what I have is a triangle and another triangle over here and a rectangle. So if I'm looking at the area as a function of theta, all right, so I have 2 triangles plus 1 rectangle. Okay, so the area of a triangle is base times height, and 1/2 of that. And since I have 2 of them, I'm going to multiply this by 2. And then the area of a rectangle is base times height. Oops. Let's make that height and this base. Base times height. Can't draw today. All right, so here we have these angles that it was lifted up, and I think your geometry teachers would be impressed if you remember that this angle and this angle are the same by the alternate interior angles if these two sides are parallel. So we've got this angle here and this angle here. This is a right triangle. So basically I've got this triangle and I have 2 of those because they're the same, and then I have a rectangle. All right, so if I am looking at this angle and I know that this side right here is 4 and it's the hypotenuse of my triangle, I'm going to say this is my height. I can say that sine of this angle is 4 over the height of the triangle. Or I can call this y because it is going up and down. Let's call that y. So I will say that again. Sine of this angle is equal to y opposite over 4. And if I solve this for y equals 4 sine theta. All right, so if I am looking at this triangle or this rectangle here, I have a length of 4 and a height of y. All right, so what about my x value right here, which would be this base of this triangle? And if I do according to this angle, this would be cosine is x over 4. So x is going to be, if I multiply by 4, 4 cosine theta. All right, so now let's look at this. I have two triangles, base times height divided by 2, but multiplied by 2. So these are really going to cancel here. And my base times my height, this is the same thing as saying x times y. If I multiply x and y together, I'm going to have 4 sine theta times 4 cosine theta. And then I have my base times height. So my base is 4 and my height is y. And y is 4 sine theta. So this is 16 sine theta cosine theta plus 16 sine theta. All right, so basically in my triangles, I labeled the sides x and y, and based on this angle here, I found the sine and cosine of those angles to solve for x and y. And then I just plug them into the area for each of these shapes. So technically this would be x times y, base times height, and this would be x times y here, and this base actually is 4. So this is 4y times xy, and this is what we end up with right here. That was kind of messy, sorry. All right, but this next part I think you'll find pretty easy. Here what we have is a triangle, and basically we are going to solve right triangles here. So when you see something that says to solve the right triangle, what we're going to do is find all the pieces. So I have an A, B, and C. These are the lengths of the sides. And I have angles A, B, and C. Now I'm going to be given some information. It says that B, and this is small b, so this is side 2. B is 2. And angle A is 40. And another thing that I know here is angle C is a right angle, so this is 90 degrees. This is given to us, it's not spelled out here, but that symbol shows us that C is 90. All right, now we have to find all the other parts. So I have to find side A, side C, and angle B. Probably the easiest thing to do would be to find angle B, because I know that 40 plus angle B has to equal 90, because all three of these add up together to be 180 minus 90 is 90. So 40 plus B is 90, so B is 50. So I'm going to put here, this is 50. Now to find angles A or C, or sides A or C, I'm looking here or here. I know I have an angle of 40 right here, and if I look at opposite and adjacent, this is a value I know. Opposite and adjacent is tangent. So if I say I have tangent of 40 equals A over C, opposite, or A over 2, opposite over adjacent, I can say that A is, if I multiply by 2, 2 times tangent of 40. And I don't have my calculator handy, but if you put in, and this is degrees, so make sure you're in degree mode. If I put in 40, tangent of 40, and then multiply that by 2, A is going to equal 1.68. And we're going to say we're going to round to 2 places after the decimal, unless the directions say otherwise. Just round to 2 places. So if A is 1.68, now I have to find C, and I could do Pythagorean theorem, where I do 1.68 squared plus 2 squared equals C squared, or I could use another trig ratio involving the length of C. So if I do the length C as the hypotenuse, if I do adjacent over hypotenuse, I have 2 over C. That would be cosine. So cosine of 40 equals 2 over C. And if I multiply by C to get it over here, and then I divide by cosine, basically I'm flipping those there, I'm going to get C equals 2 divided by cosine 40. Okay, so 2 divided by cosine of 40 is 2.61. And that's my value for side C. Now remember that C has to be the longest side, so 2.61 is the longest, and the sum of these two can't be more than 2.61. All right, so you can't add these together to get more than 2.61. Or, sorry, I said that wrong. No, I didn't. You can't add them together to get more than 2.61. So in example 3, I have 2 values here, and it says to find these 3. So I like to just set it up. I have 3 sides and 3 angles, and it says side A is 3, side B is 2, and then I always know that side C is 90. All right, so now I need to find the length of side C and the angles for A and B. Well, side C I can do with the Pythagorean theorem, where I have 3 squared plus 2 squared equals C squared. So this is 9 plus 4, so C is the square root of 13. Okay. Now, if I want to find angle A, the trig ratio that involves the 2 sides that we know are opposite and adjacent, so that would be tangent. So tangent of angle A is 3 over 2. Okay. Now we've done some solving equations. If I want to find out what that angle is, and that's what this is saying, tangent of what angle is 3 over 2? I need to do the inverse tangent. And when I do that, remember these will cancel, and I'll have A is inverse tangent of 3 over 2. And if you do that on a calculator or on Desmos, inverse tangent 3 divided by 2 is 56.3 degrees. And that is angle A. Angle B, I could do opposite over adjacent. So here I can do angle B is inverse tan of opposite is 2 over 3. Or I could have, knowing that these two angles add up to 90, I could say that 90 minus angle A is angle B, and angle A I know is 56.3. So if I subtract 90 minus 56.3, I have 33.7. And I think we're going to stop right there for now.